All right, thanks very much. Well, thank you first of all to ANSI for hosting this webinar. It's an extremely important topic. And thanks for your time, all of those who are listening. So my name is Frank Menchaca, and I am the chair of the SAE Global Battery Traceability Committee. And I'm here to talk to you today about a standard that we have written called J3327. So maybe let's go to the next slide. And maybe one more click. There we go. So this is a standard about creating a procedure or a process, consistent process for gathering essential data that would go into a battery traceability record. And it goes without saying that a big part of that record are the critical minerals. So as a way of kind of giving you a little bit of background, I always kind of start with this quote from IEA. Traceability systems can enable the collection of data on product origin, geographic path, the sequence of entities that held ownership or control over the product and its physical evolution. So I'm sure all of you know all about traceability, but it's worth reiterating how important it is in kind of establishing a product's origins, the way it was manufactured, and the materials that are in it. And as we think and talk about critical minerals, obviously traceability is a big part of getting our hands around the critical minerals supply chain. And so a question that we sought to address with this standard is how can a traceability system for electric vehicle batteries advance the energy storage industry? And so let's go to the next slide. So a number of organizations came together to really address this question. One is LIBridge, which is a program of the Federal Consortium for Advanced Batteries, part of the Department of Energy, and it's administered through Argonne National Labs. And then, of course, SAE International, which is the oldest and largest standards organization for engineers in aerospace, automotive, and commercial vehicle. And so, LIBridge really kind of sponsored this in cooperation with these other entities. So next slide. So a little more than almost 2 years ago, or a little bit less than 2 years ago, in August of 2024, Argonne National Lab, Federal Consortium for Advanced Batteries, and LIBridge convened a meeting at Argonne National Lab and attracted representatives of a little bit over 50 companies up and down the supply chain for batteries, and specifically for electric vehicle batteries, to attend a 2-day workshop at ANL. And the goal was to really understand industry's position on traceability. And there are a few reasons for that. One is that there were at the time and still are tax credits, in this case, battery production tax credits that are available. There is an impending European Union digital product passport. And we really tried to use this opportunity to understand where industry's thinking was in being able to comply with these regulations and opportunities that were on the horizon. And what came out of that meeting is that there is really an uneven capability to comply with tax credits, foreign entity requirements, particularly around things like forced labor, and the EU digital product passport. No companies seem to have it sort of licked, so to speak, in how to comply with this. Very big companies with lots of resources were further ahead, but smaller and medium-sized players were challenged. So there's no common procedure for reporting on traceability. There seemed to be a desire for a standard that could be used that doesn't generate extra work or cost. So the message that came from industry is, yes, we could use assistance in having some kind of consistent procedure for building a battery traceability record in order to comply with some of these things. but we don't want it to create extra work and extra cost. And there was a desire to see this done in 12 months or less. And so those were, if you like, the working principles that came out of that meeting. So next slide. So that really gave kind of the shape and the frame to SAE 3327. So that is the formal title is Surface Vehicle EV Battery Traceability Record. It was published on September 8th of 2025. The timeline, just as a matter of interest, we started right after the Liebridge meeting in August of 2024. We sort of revived an SAE committee that had been dormant. And by March of 2025, we had an initial draft. And by September of 2025, we published what is the first step in the standardization process at SAE, a technical information report. There were 88 members, good involvement across participants. So some key names: GM, Ford, Nissan, Honda, Honeywell, CATL, NIST, Symbichain, Denso, Omron, Daimler, Enersys. And so broadly, what the standard really set out to do was to create a consistent shared format and vocabulary for creating a battery traceability record. And that means identifying and recording battery information, critical minerals contained within the battery components, chain of custody, in other words, ownership of materials, components, and products along the way, including critical minerals. We took it as a guiding principle to leverage existing standardization in one common global practice. So we had representatives from DIN, the German national standards body that was writing a data standard for the EU Digital Product Passport. We had folks from the European Commission, the Global Battery Alliance, and a number of organizations. We really tried not to contravene existing standards, but to find something, to find a pathway to add something and synthesize what was already being done in order to codify it into one consistent practice. And one thing I think that's really important to understand about this standard is that everything in it ties to a requirement of some kind. And so we were very careful in setting the boundaries of the standard not to create something that was discretionary, but rather essential. And essential in the sense that all of the requirements in it tie to a requirement either for the EU Digital Product Passport, compliance with the tax credits, or the National Defense Authorization Act, which was something that we encountered along the way. And so the overall thrust of it was to ease the data collection for compliance with all of those things. So next slide. So here's a little bit of a look into what the standard looks like. On the left, you'll see a table, and these are the requirements of the standard. So if you drop down to battery chemistry, since we're talking about critical minerals, you'll see that we say the standard requires an itemized list of applicable critical minerals. Applicable critical minerals is the precise name that is given for the battery production tax credits. And so we identify what unit of data that is. It's just a string. We identify whether or not it's static or dynamic. We identify whether it's mandatory or recommended, and is it required for the EU, the US, or both. And this goes over a range of requirements. But as far as critical minerals go, we list those out in the standards based on the information that we received from the Department of Energy. And I'll hasten to add, Department of Energy took a very critical role in helping us to shape the standard. The co-chair of the committee is an ANL scientist who is working with the folks at DOE. So we really made, I think, an effort to try and coordinate between industry and government. And so we really are looking to organize and harmonize with the EU Digital Product Passport as well in the following areas. So entity information, battery chemistry, extraction information, manufacturing and processing information, and then component information. As I mentioned, as we were developing the standard, there was a development of the National Defense Authorization Act, a set of requirements covered in Section 842 around batteries, and we made sure that we tied out to that as well. We did depart from the EU Digital Product Passport in some important ways that were out of scope. One is that we didn't have a public disclosure of information. There wasn't carbon footprinting. So once again, the standard really is a very focused use case around including anything that was cited in regulation, but not including material or requirements that were considered to be extra or discretionary. In addition to creating the standard, we also did a proof of concept. So I worked with a committee member. Essentially, we gave ourselves the assignment of if we were working in a company and a stakeholder came in and said, here's the standard, I want you to follow it and go and create a battery traceability record, how would we do it? And so working with a committee member, we wrote a technical paper that really follows how we would create the traceability record. We utilized a number of ISO standards in that process, and I'll call those out. We used the chain of custody standard for accounting methods, ISO 13662. We chose a mass balance accounting model. And if anyone is interested in this paper, it's freely available, it's publicly available. I'd be happy to provide it. And then another standard we found really useful in this is traceability of rare earths in the supply chain from mine to separated product, which is ISO 23664. Although rare earths are different from critical minerals, we found this to be a very useful standard in kind of creating a methodology for organizing information that is being sourced from mines. And so I think the point of this is that there is an actual paper that tries to implement this. Maybe not surprisingly, it turned out to be a little bit more complicated than we thought. It was a non-trivial effort, but we managed to do it. We thought it was important that the methodology that we chose to create the traceability record and fulfill the requirements really be compliant to the greatest degree possible with existing standards. And that's why we tied back to ISO standards in creating this. So next slide. So we published in September 2025, and since then we've been working in two parallel tracks. We are in the process of revising the standard for a 2.0, and in SAE lingo, that is a recommended practice. That's kind of the second step in the SAE process. And that really consists of incorporating changes to the battery production tax credit. There are new rules and regulations around prohibited foreign entities and specified foreign entities. And so we are in the process of defining those from guidance that is coming out of the IRS. And we expect final guidance to come out later this year. And we will include all of those updates in the next version of the standards. We're running pilots of the standard, and that's an ongoing process. And any kind of improvements or suggestions for improvements that come out of that, we're incorporating. It's worth mentioning that one suggestion we've had so far is to have some form of voluntary verification. And so we've built that in. I'll show you what that looks like in a minute. And then, of course, I mentioned the National Defense Authorization Act, and we're looking to harmonize with information that's needed for compliance there. And then, of course, any updates to the EU Digital Product Passport. And I mentioned the verification. So next slide. So this is a little bit of what the guidance on foreign sources or foreign entities looks like. We have combed through the existing information from the Federal Register and the IRS, and you'll see that we're providing definitions. There are a dense set of definitions. We're trying to make them accessible. But you can see that we are sourcing everything and tying back to the source so that there's really no requirement to do anything extra, but we're really trying to make clear what is required in order to meet some of the foreign entity requirements. And so you can expect to see that in the next version of the standard. And then next slide. And then as an appendix, we've created a voluntary verification schema. And we've had some input from NIST on this. We've also taken input from the German battery pass, the EU recommendations for verification from Sensenelec, data integrity models, and then, of course, industry feedback. And it's a 5-level verification schema that goes from no verification to very high levels of verification. We did some basic risk assessment for each level, and we did some discussion of what kind of documentation should be provided. So next slide. So a little bit about next steps. We have ongoing pilots and industry feedback. We expect by Q4 2026 to finalize the next version with the 45X or battery production tax credits, National Defense Authorization Act information, and any changes to the EU Digital Product Passport. And we expect to publish the next version of the standard as a recommended practice in the first quarter of 2027. We are in close touch with several ISO committees that are working in this area. And we also welcome anyone who wants to join the committee. There's lots of ways to get involved. You can be a liaison. You can listen in to the meetings. It's the SAE standard development process is an open one. And so anyone is welcome to sit in and listen in. You can become a voting member and get involved in actually reviewing the document, providing feedback, working with us to create revisions. And I'll hasten to add that we're going to have a recapitulation of the original LiveBridge meeting that occurred in August of 2024. That'll be in September of 2026, where we come back to talk about what's happened since the first meeting, talk about new issues that have arisen in traceability, new opportunities that have come up with new kinds of technology that are being applied to traceability. So I think it's worth kind of noting that our approach here is we wanted to tie back to regulations. We wanted to create something that could be updated on a dynamic basis that reflected kind of the dynamic aspects of the topic. And we'll continue to monitor and revise accordingly as industry requires us to. So with that, I'll cede the floor back, and thank you for your time, and I'm happy to answer any questions that may have come up.